Okay, what I want to show you in this activity is what a list is in Erlang, how we build them up and how we deconstruct them. So let's take a look at what we mean by a list. Simply enough, a list is a collection of elements. For example, the list 2, 3, 4, 2. Now the point about this, it's a particular kind of collection in which the order matters. So the list 2, 3, 4, 2 is not the same as the list 2, 4, 2, 3. The order matters. So the first element is 2, the second element is 3, and so on. And also, multiplicity matters. The number of times an element occurs matters. So the list 2, 2, 3, 4 is different from the list 2, 3, 4. So it's a collection where the order of things matters and the multiplicity matters. Now, there's a particular list, the empty list, which we write just as open and close square parentheses, or otherwise a list is non-empty, so it's got at least one element. Now, in the case that it's non-empty, it matches the pattern x, I'm going to say x cons x's. And this is written in square brackets, x vertical bar x's close square brackets. It's not the most elegant of notations. It's inherited from Prolog. If you wanted to read, there's a very nice article on the history of Erlang. You could see that one of the languages that fed into the development of Erlang was Prolog. But we're just going to live with this. We've got every list will either match the empty pattern or it will match this pattern x cons x's, where x matches the first element and we call that the head, and x's, and you can see I'm pronouncing xx as x's to suggest that there's more than one. There are a number of things in there. It's a list. So x's matches the rest of the list, which is a list itself, the tail. So the first element is an element. If we've got a list of numbers, it's a number, whereas the tail is a list of numbers. So in a particular example, if we've got the list 2, 3, 4, 5, and we match it to the pattern x cons x's, then x matches the head of the list, which is 2, and x's matches the tail of the list, which is the list 3, 4, 5. So the lesson from this, every list is either empty or non-empty, and all non-empty lists match this pattern x cons x's. Okay. Now, I'm not going to show you this, but if you want, what you could do is fire up a shell and try these things for yourself. What you're going to do in the next activity is you're going to have a collection of things to do like this, but if you want to follow along with what I'm doing, fire up an Erlang shell and try things out. So if we say in the shell x cons x's equals list 2, 3, 4, 5, we get back the answer 2, 3, 4, 5, that's the value of that expression, and then if we ask for x we get the value 2, we ask for x's, we get the list 3, 4, 5. So you can see it's doing precisely what I suggested. Now we can write some simple list functions straight away. We can write some deconstruction functions. A function to take the head of x cons x's will just return x, and the function to take the tail of x cons x's will just return x's. Now you can see I've done something different here. I've made sure that I begin the patterns, the parts of the pattern which I don't use, in the first case the x's, in the second case the x, by prefacing that with an underscore. I could have just put an underscore on its own, but sometimes it's nice to have that underscore x's to remind us that the thing that will be being matched there is a list, and the underscore x reminds us the thing at the head, the second pattern, is an element. So there we've got a way of deconstructing a list. Now suppose we wanted to find the second element of a list, assuming it's got at least 2 elements. What could we do? Well, we could do it using our functions head and tail. How could we do that? Just take a second to think. Yes, you're right. What we do is take the tail, which throws away the first element, and then take the head of that. So we can say second of x's is head of tail of x's. And you can see here we're doing something, we'll see this all the way through this week, We don't always define functions from scratch, but we can reuse functions we've already written. Typically, one of the most useful ways of reusing functions is to do what's called function composition. You first apply one function, then another, and that's exactly what I'm doing here. I'm saying first take the tail, then take the head. But we could do it using patterns, and you can write a more complex pattern. On the left of the vertical bar, we put two variables. So those two variables will match the first two elements of the list, and then whatever follows the vertical bar matches whatever remains of the list. So here we've said x, y, vertical bar z's. X will match the first element, y will match the second, and z's will match the tail of the tail. What remains when you remove the first two elements. But again, I've used underscores in order to suppress the warnings that the Erlang system would give me. And this directly shows that what I'm getting here is the second element of the list, the element y in this case. So what we've seen is every list can be seen as matching the pattern empty list or the pattern x cons x's, where x matches the head, the first element, and x's matches the tail, the remainder of the list. And we've seen that when we're looking at lists, the order of the elements matters and the multiplicity of the elements matter. So the next activity is for you to have a try of these things yourselves in the shell. Okay, over to you.